The next conic section we're going to be studying is parabolas. Now, we've looked at parabolas before, but we've only focused on the vertex of the parabola and the axis of symmetry of the parabola, and how it creates symmetry to the left and to the right of the parabola. So these distances were always equal. Now we're going to be looking at more characteristics that each parabola has. We define a parabola to be all of the points that are the same distance away from a fixed point in a fixed line. Now, this fixed point is not on the line, and it's called the focus. So in these two different types of parabolas, a vertical and horizontal parabola, you can see that the focus is on the inside of the curve. Okay, so our fixed point that we're talking about is called the focus. Now, the fixed line is the directrix. And the directrix is on the opposite side of the parabola as the focus, so it is not on the inside. Okay, it's either underneath it, above it, or to the left or to the right of it. Now, the distance between the focus and our vertex, so we still have our vertex in each parabola, the distance between the focus and the vertex is called the focal length. Okay, so the distance between these 2 points is the focal length. And of course, we still have our axis of symmetry, okay? And if you notice, the axis of symmetry goes through the focus, goes through the vertex, and then it intersects with the directrix. When it intersects with the directrix, it's actually perpendicular. There are two different forms that you can see a parabola in. You can see it in standard form, which is when you have ax squared plus bx plus c, or you can have it in vertex form. Now, we also have two different types of parabolas we're going to be looking at. Vertical parabolas, which open up or down, and those are going to be functions. And then we're going to talk about horizontal in just a second. Now, if they're vertical, they're always y equals, and then our vertex is hk in vertex form, where h is next to the x-coordinate and k is on the outside. And remember, we still have our focus and our directrix. And we're going to be examining the characteristics of those more in depth in just a second. Now, whenever we have a horizontal parabola, which means it opens to the left or to the right, things are a little bit different. So now our squared terms are y, so we have a y squared plus by plus c equals x. Now that means that when we find our vertex using the standard form, negative b over 2a is now the y coordinate. Okay? Now same thing goes when we're in vertex form. It's no longer hk, k is now next to the y value. Okay, so be very careful of this. K, which is the y coordinate of the vertex, will be next to the y since we are horizontal and our square term is y now. So let's review everything. We have our vertex, then we have our focus, which is on the inside of the parabola, and then we have our directrix. Now, the distance between the vertex and the focus is called the focal length, and that is represented by c. So c, remember, is our focal length. Now, the distance between the vertex and then the directrix is that same length. Okay, so there's some symmetry there. It's the same length. Now, remember, the parabola is created by these lengths always being congruent. That's how we get all of the points on the parabola. Now, it's important to remember that where c comes in is a, the absolute value of a equals 1 over 4c. Now, what does a mean? Remember, a is always the coefficient of our squared term. So when it's a vertical parabola, we have that equation, and when it's a horizontal parabola, a is in front of the y squared term now. So a is going to be important. A is always 1 over 4c, where c is our focal length. To find the equation of the parabola, we have to use all of the symmetry that this parabola has. The first thing that's going to be very important on each problem is to sketch the information you're given. Okay, so for this problem, I'm given that the vertex is at 0, 0, the origin, and the focus is at 0, 2. So next to the problem, you need to make a little sketch of what this parabola is going to look like. So if the vertex is at 0, 0, to go from 0, 0 to 0, 2, I don't move left or right, I go up 2. Okay, now remember, your focus is on the inside of your parabola, so that means my parabola must open up like this. Because I open up, I know when I get closer to the end of my problem, my leading coefficient must be positive. Now, what is the equation of a parabola that opens up? It's y equals ax squared plus bx plus c, or a times x minus h squared plus k. Now my vertex is 0, 0, which means that this part goes away, or if you want to reduce the vertex form, it's a times x, I put a 0 there so it becomes squared, and k is 0 so that goes away. So my equation is y equals ax squared. So all I need to find is a. We have to use that a is always equal to 1 over 4c, where c is the distance between the vertex and the focus. It's the focal length. Now from vertex to focus, I went up 2, so c is equal to 2. So I'm going to plug that in, 1 over 4 times 2. So a is going to be equal to 1/8. Now because we open up, I know that a will be positive. So my final answer here will be y equals 1/8 x squared. So now we want to find the focus and the directrix just given the equation of the parabola. Now looking at this equation, hopefully we can tell that the vertex will be at 0, 0. Now the reason I can tell that right away is that the vertex form of a parabola is this. Now if all I am seeing is ax squared, that means h and k had to both be 0, so the vertex is 0, 0. Now by looking at this equation, we can see a. A is going to be 1/12. Now I don't take the sign of a because remember that negative only tells me that the parabola will open down. So the sign of a just tells me the orientation of the parabola. Now a is 1/12. How am I going to figure out the focus and the directrix? Well, I need to know the focal length. Recall that a is equal to 1 over 4c, where c is the focal length. So 1/12 is equal to 1 over 4c. Cross multiplying, we get 4c equals 12. So c will be 3. For each of these problems, you should have a sketch of what the parabola will look like. So because I know my vertex is at 0, 0, and a is negative, so remember a was negative, which means that my parabola will be opening down. Now your focus is always located on the inside of the parabola. So that means my focus is on the inside of the parabola. We just want to figure out at what coordinate. And then the directrix is on the other side of the parabola. And we want to find the equation of that line. Well, it's a horizontal line, so it will be y equals. I just need to figure out how far away is it from the vertex. Well, that's the focal length, which we found already to be 3. So 3 away, and then 3 away. Remember, those are always congruent. Well, if I'm at 0, 0 and I travel down 3, then I'm going to end up at 0, negative 3. If I'm at 0, 0 and I travel up 3 to this line, that means this line will be y equals 3. So the directrix is going to be y equals 3. And my focus will be at 0, negative 3. Now we're given the equation of a parabola in standard form and want to find the vertex, the focus, and the directrix. Now in order to do that, I need to know what the vertex is first. Now looking at this equation, I can tell that the vertex will not be 0, 0 because I have a b term. Now there are 2 ways to find the vertex. You can use negative b over 2a and then plug that back in to find the vertex. Or you can complete the square and rewrite it in vertex form to find the vertex. because we need practice completing the square, I'm going to use that method. So we need to find the value that will complete the square and make this a perfect square trinomial. Since I'm going to be adding this value here to make this a perfect square trinomial, that would mean that I would have to add that value to the left-hand side of the equation. Now, because we like the equation of a parabola to be equal to y, instead of adding it there, I'm just going to take it away from the 8. So I'm adding it here, but then taking it away so my equation stays balanced. In order to find this missing value, we take our b term, and it's always b over 2. So I'm going to do negative 4 over 2, which gives me negative 2. So I'm going to have y equals x minus 2 squared. And to find the actual missing value, you square that term. So the missing value here is going to be 4. So I'm going to add 4 here, but then take it away over here. So now we've created this perfect square trinomial, which factors into this. And then simplifying 8 minus 4, we get plus 4. So my vertex will be at 2, 4. Now I just need my focus and my directrix. The key to finding your focus and your directrix is your focal length, which is c. Now remember, c is related to a, which is the coefficient here of x, which is also here. Now since a was 1 here, a is also 1 in vertex form. So we have that a equals 1, but a is also equal to 1 over 4c. So 1 equals 1 over 4c, cross multiplying. We get 4c equals 1, so c is going to be 1/4. Now because a is positive 1, we know we are going to be opening upward. My vertex is at 2, 4. And I know that my focal length is 1/4, so I'm going to be traveling up 1/4 to get to my focus and down 1/4 to get to my directrix. Since I'm going up and down, only the y value will change. So since my x value does not change for the focus, I'm just going to take 4 and add 1/4. So adding 1/4 to 4, I get 17 over 4. Subtracting 1/4 from 4, I will get 15/4 for my directrix. So y equals 15/4 will be my directrix, and my focus will be 2, 17/4, and my vertex is 2, 4. Now I want you to give these a try. Remember, for each of these you should sketch what it should look like so you can figure out the orientation.